You've got a table sitting at 20% dead tuples, queries are getting slower, and Autovacuum just isn't keeping up. This isn't a bug. Autovacuum is hitting its design limits. I'm going to show you exactly why it falls behind and how to tune it for workloads that blow past the defaults.
So it's not that Autovacuum is broken, it's just not tuned for my workload?
Right. The defaults are conservative on purpose. I'll walk you through the cost throttles, worker bottlenecks, and per-table scale factors that actually matter, plus the exact alter table commands you need for hot tables. First thing, cost limits. Autovacuum deliberately throttles itself so it doesn't steal all your I/O from queries. Autovacuum tracks a cost budget. Every buffer it reads costs 1 point by default. That's vacuum cost page hit. Every page it dirties costs 20, vacuum cost page dirty. When the accumulated cost reaches the configured limit, Autovacuum sleeps for a few milliseconds to avoid overwhelming your I/O.
So if I've got a big table with tons of dead tuples, it's constantly hitting that limit and sleeping?
Yeah, the default cost limit is 200 points per worker. On a write-heavy workload, Autovacuum spends more time sleeping than working. You can see this in pgstat progress vacuum. The phase will say scanning heap, but progress is glacial. Here's what you're tuning. Autovacuum vacuum cost limit defaults to 200. That's the budget per worker unless overridden. The delay is 2 milliseconds per cost unit by default, so workers sleep periodically as they accumulate cost.
Wait, so each worker has its own budget?
Right. Each worker operates with its own cost limit. More workers help with concurrency, vacuuming multiple tables at once, and each can be tuned independently per table. For most production systems, the default 200 is way too low. Bumping it to 2000 or even 4000 is common on modern SSDs. You're giving Autovacuum workers 10 to 20 times more I/O budget before they sleep. Just make sure you monitor your disk I/O so you're not starving queries.
And this applies globally to all tables?
Right. This is the cluster-wide setting. We'll get to per-table overrides in a minute. That's where you really dial in hot tables. Next bottleneck, worker count. By default, Postgres is configured to run up to 3 Autovacuum workers at once. Each Autovacuum worker handles 1 table at a time. If you've got 100 tables that all need vacuuming, only 3 are being worked on. The rest wait. On a busy database with lots of small, high-churn tables, you can easily have a backlog.
So even if I raise the cost limit, if I've got more tables than workers, some just sit there?
Yep. You can monitor Autovacuum activity using pgstat activity to see active Autovacuum workers. If you're always maxed out at 3 and you've got tables with rising dead-tuple counts, bump Autovacuum max workers to 6 or 10. Raise the worker count when you've got dozens of tables that churn frequently. Think multi-tenant setups or event logging tables. If vacuums finish quickly but there's always a queue, more workers help. You can confirm by querying pgstat activity for Autovacuum processes if you're always at the max and pgstat user tables shows dead tuples piling up elsewhere. That's your signal.
Got it. So it's really about concurrency, not speed per table.
Exactly. 1 worker on 1 huge table won't go faster with more workers, but 10 workers can vacuum 10 tables at once. Now the big one, scale factors. This is why Autovacuum may not keep up with very active tables if not properly tuned. Autovacuum triggers based on a combination of a fixed threshold and a percentage of the table size. The threshold is Autovacuum vacuum threshold, default 50, plus Autovacuum vacuum scale factor times the table's total tuple count. The scale factor defaults to 0.2, so a table typically needs to accumulate dead tuples equal to roughly 20% of its size before Autovacuum even starts.
Wait, so a 10 million row table has to accumulate around 2 million dead tuples before Autovacuum kicks in?
Exactly. And if that table is getting 1,000 updates per second, it'll hit that threshold fast. But then Autovacuum may struggle to keep up with the rate of updates depending on your tuning and available resources, leading to multiple runs to clean the accumulating dead tuples. Meanwhile, queries are scanning all that bloat. This is the classic Autovacuum lag on hot tables. Run this query to see which tables have the highest dead tuple percentage. Anything above 10% on a large active table is a red flag. It means Autovacuum either hasn't run yet or it's running but can't keep pace.
So for those hot tables, I want to lower the scale factor so Autovacuum starts sooner?
Exactly. And you probably also want to raise the cost limit per table so it finishes faster. Let's look at the exact alter table syntax. Here's where you fix hot tables, per table storage parameters that override the global defaults. For a hot table, say your orders table, you want to lower the scale factor to 0.02 or even 0.01. That means Autovacuum triggers at 2% or 1% dead tuples instead of 20%. Then raise the cost limit to 10,000 so it runs fast, and optionally set the delay to 0 so it doesn't sleep at all on this table.
Won't that hammer my disk I/O?
It can, so monitor it. But on modern SSDs, a single Autovacuum worker with no throttle is usually fine. You're trading a bit of I/O for way less bloat and faster queries. The key is you're doing this per table, not globally, so only your hottest tables run unthrottled. These are the 5 per table knobs you'll use. For scale factor, 0.01 to 0.05 is typical for hot tables. That's 1% to 5% dead tuples. Raising the cost limit gives it real throughput. Try 10,000 or higher based on your I/O capacity. Setting delay to 0 removes the sleep entirely, but watch your disk. And don't forget Autovacuum Analyze Scale Factor. If your table's data distribution changes fast, you want stats refreshed sooner too.
So I'm basically telling Autovacuum, run sooner, run harder, just on this table.
Exactly. You're giving it a dedicated fast lane. The rest of your tables still use the global defaults, so you're not over-vacuuming everything. By the way, my DBA's free health check spots exactly this. It tracks dead tuple ratios and auto-vacuum progress across all your tables, flags the ones falling behind, and gives you the exact alter table commands with tuned scale factors and cost limits. You connect your database, and within a week, you've got a full report that keeps updating. Let's talk about the specific workload patterns that make Autovacuum fall behind, even with reasonable settings. 2 patterns are especially brutal. First, high-frequency updates on the same rows. Think a status column flipping every few seconds. Each update creates a new tuple version, so dead tuples pile up fast. Second, batch delete plus insert cycles, like purging old data and loading new data every hour. Both can generate dead tuples faster than Autovacuum can clean them, especially on large tables with the default scale factor.
So even if Autovacuum is running, it just can't keep up with the write rate?
Right. If you're updating 1,000,000 rows an hour, an Autovacuum triggers based on a combination of threshold and table size percentage. By the time it starts, you've got another 1,000,000 dead tuples queued up. Lowering the scale factor to 1% or 2% means it runs more often, catching the bloat before it spirals. Here's a sneaky one. Long-running transactions. Even if Autovacuum runs, it can't remove dead tuples that are still visible to an open transaction. Postgres tracks the oldest transaction ID, that's XMM, and any tuple newer than that has to stay. So if you've got a report query that's been running for an hour, Autovacuum will scan the table, but won't actually free much space.
So I could have Autovacuum running constantly and still see bloat piling up?
Exactly. Check PG stat activity for queries with old backend, XMN, or exact start values. Killing or finishing those transactions lets Autovacuum actually do its job. This is also why idle in transaction sessions are so dangerous. They hold a transaction open, blocking cleanup across the whole cluster. A few more gotchas. Low cost limit, the default per worker 200, may make Autovacuum crawl on some hardware. Too few workers means tables queue up. Large tables, with the default 20% scale factor, means Autovacuum doesn't start until a significant portion of the table's tuples are dead. And on replicas, if hot standby feedback is on, the standby's queries can hold the primary's XMN, blocking cleanup there too.
What about manual vacuum? Does that interfere?
It can. If you run a manual vacuum with a high-cost delay, it'll block Autovacuum from starting on that table. Autovacuum won't double up, so if you're running manual vacuums, make sure they finish quickly or Autovacuum just waits. Run this to find transactions that have been open for more than 10 minutes. Anything in the hours range is a problem. It's holding XMN and blocking Autovacuum from reclaiming space. You'll need to either finish that query, kill it, or redesign your workload to avoid long transactions.
So tuning Autovacuum isn't enough if I've got application-level issues like long-running reports.
Exactly. Autovacuum tuning buys you a lot, but you also need to keep transactions short and avoid idle in-transaction sessions. It's a system-level problem, not just a config tweak. Once you've tuned Autovacuum, monitor it with pgstat progress vacuum. It shows which table is being vacuumed, what phase it's in, scanning heap, vacuuming indexes, cleaning up, and how many blocks it's processed versus the total. If you see it stuck in scanning heap for hours, that's a sign it's cost throttled or blocked by a long transaction.
So I can actually watch Autovacuum work in real time?
Yep. It's super useful for confirming your tuning worked. After you raise the cost limit or lower the scale factor, check pgstat progress vacuum and you should see it moving through tables faster. So that's why Autovacuum falls behind. Cost throttles, worker bottlenecks, scale factors that don't match your workload, and blockers like long transactions. My DBA's free health check finds all of this automatically. It tracks dead-tuple ratios, flags tables where Autovacuum is lagging, and hands you the exact alter table commands with tuned scale factors and cost limits for each hot table. You connect your database, and within a week you've got a comprehensive report across 16 domains, and it keeps updating every week. Head to my dba.dev and run your free health check now.